Yeah, welcome. This session we will dedicate to the gate model question, as most of you are asking for the gate model question. So I thought of discussing the gate model question in this session. Right. You see it here. This is one such model question appeared in 2022. It is related to structural analysis. So the question you see here, consider the linearly elastic plane frame shown in the figure. The members H, F, F, K and F, G are welded together, which means it is a rigid joint. Okay, you shall understand that joint is a rigid joint. Joints F, G, H are fixed. These are fixed joints. Okay, a counterclockwise moment M is applied at joint F. Consider flexural rigidity for each member as 10 power 5 kilonewton meter square and neglect axial deformations. Okay. So if the magnitude of the support moment is at H is 10, here the moment is 10 kilonewton meter. The magnitude of the applied moment M to maintain static equilibrium is, what is this M value? That's the question. Okay, right. This is purely based on the moment distribution concept. Okay, so that you can apply it here. You see, distribution factor for each of these members, if you are able to calculate, you see, it is by the formula distribution factor is equal to K by sigma K. Okay, and the stiffness of each member, that is FH, FK and FG, are formulated by the formula called 4EI by L, because all the forends are fixed. You see, for all members all these forends are fixed, so the stiffness of the member is 4EI by L, and all three members are of the same end condition, so 4EI by L. Then what will be the distribution factor? It is 1 by 3. Okay, because all the members are of same EI and same length also. You see, this is 5 meters and this is also 5 meters. This is also 5 meters. Okay, so if I add all these three by keeping 4EI by L as common, so I get into 3 times. Okay, this is the joint stiffness. So the member stiffness is 4EI by L. The joint stiffness is 3 times of that. So you get distribution factors for each member as K by sigma K, that is 4EI by L divided by 3 times of 4EI by L. So this goes and 1 by 3 remains. So this is the distribution factor for each member. Okay, now continue. Now you have been given with this 10 kilonewton meter at this point, that is H, right? You see it here, 10. Okay, so from the carryover moment concept, okay, so this, there is a 10 kilonewton moment here. So how much would have been at this point? Okay, so that is by carryover factor. So what is carryover factor? The moment applied at this point divided by the moment carried to the far end. So this is MHF. MHF is the carryover moment. Carryover factor is equal to carryover moment by applied moment. Okay, so that MHF divided by MFH. Okay, for that particular member, because you have the given data for this member only. That's why we are starting at this point, our solution, right? So carryover factor is, for when for end is fixed, it is 1 by 2. Okay. So from this, you are able to find what is MFH value by cross multiplication. You see, 2 times it is 10. MHF value is 10. So 2 times 10 is 20. Okay. So going further, so now you know that there is a moment at F for member FH is 20 kilonewton meter, right? Then from the distribution factor formula, not in terms of stiffness, in terms of moment shared at the joint, you see, this is the moment shared at the joint. So moment shared at the joint MFH for that particular member divided by total moment applied at the joint. That is a formula for distribution factor again in terms of moments. That if you use, distribution factor is 1 by 3 for that particular member, and moment shared to that member is MFH by M. You know this value, that is just found 20. So 20 you cross multiply. So 20 into 3 is 60. So the applied moment at the joint is 60 kilonewton meter. So that is the solution for this question. And you can see the concepts here are well known to you and well used, like what is distribution factor in terms of stiffness as well as in terms of moments, and what is carryover factor for the foreign fixed case, and what is carryover moment. So all these concepts are very well learned in moment distribution method, right?